All right. Good morning, everyone. Good afternoon if here on the East Coast. So lately, what we've been doing is preparing the CAP to get it reviewed and make it a part of make this proposal a part of the next Kubernetes release. When I say this proposal, I mean the bucket API cozy. Uh, See some new people here, so I figured I'll give a quick background. All right, so I'm sharing my screen. What I'm showing here is the current design. So the current cap, this is what's there in the pull request too. Um, and as I was writing more of the cap, one thing I realized was when provisioning buckets into pods, the structure that goes into a pod, we haven't completely worked out yet. Because earlier we were relying on this structure to be the protocol field. Now the protocol field has been slashed for the most part, to
for
almost nothing.
for um for bucket requests, right? Not for
For
bucket
for
accesses.
for bucket request, yeah, not for the access
So
resource.
so so my thought had been that the bucket access is going to be where all that information goes.
Oh, okay, but we still need to figure out. Interesting. That makes sense. Now we still need to figure out how we'll get
Because
information back.
it's information that comes from the plugin back to the sidecar, right? So the so
You
so
could
you
say that.
you created an S3 bucket, and at that point you don't know how to connect to it because no one has access. Then you create an access request, and you go down to the sidecar and it calls grant access, and then the plugin returns back, here is your access key, here is your secret, here is your endpoint, here's all your stuff.
Right.
and and
Fair enough.
then you store that in the bucket access object in some S3 specific structure, and then that's
Right.
what
That
gets
structure has
eventually
to be
passed
worked
down to
out.
the pod.
Right. Right. So that structure has to be worked out in the sense that, in a sense, we have to define it somewhere, number one. And number two is the gRPC API has to be updated
Right,
to
right,
return this structure.
and that's what I've been trying to get to with all of this focus on the downward API, is getting to that discussion.
Mm-hmm. Yeah. So, here's, I don't know if it's visible. How to make it bigger. Let me go to GitHub. All right. So just so I can zoom in. All right. All right. So here is how I've written it right now. Just based on what seems most logical. Um, I think at some point we were deciding we thought we should call it bucket info. I mean, it doesn't have to be a well-defined resource, though it is preferable to have it that way because people can read the definition. Um, but per protocol, it's going to have a different set of fields, and I agree that getting these fields as a response to bucket access create makes sense. Um, Now, earlier we had this idea where we would have a bucket.json and a separate credentials file. And the reason for the credentials file was that if you have existing clients for say AWS, they wouldn't, and if you put the credentials file in a standard path, they wouldn't have to learn the Cozy API or figure out how to read from Cozy. They could just turnkey start using Cozy. But since we introduced bucket.json, that's not possible anyways, because they'll have to read bucket.json.
Well, I thought that the theory was that no matter what we define as the downward interface, you could use something like an init container to handle the impedance mismatch of converting whatever we provide to a standard format, so that the application running in the real container
Sure.
still doesn't need to change, right?
Yeah, it can still be done.
So
So I'm just advocating
if
for
we agree
one
that
file.
that's an acceptable workaround, then that frees us up to just create the downward API the way we think it should be.
Right, right. That's what I'm saying. This is how it
Okay.
should be. I'm saying it should have just one file. It doesn't need two files or multiple files.
Right. Okay. And anyone who comes to us and says, I want multiple files, we tell them, well, write in a init container that generates what you want.
Mhm.
Okay.
That's right. Yeah. Okay. So per protocol, I'm thinking we'll have separate structures. Um, yeah, I don't think we need to abstract out common fields across protocols. We'll just leave them as it is inside the protocol structure. Sure, things like endpoint and name
Sid,
name
we
itself
lost the
is gonna,
audio.
well,
Just
I,
briefly, you went out and it was
I,
silent.
oh, I was saying, it's better to have it is better to have the protocol structure just have its own fields like stuff like name and endpoint or bucket ID. An endpoint can kind of be extracted out, but then as we saw with in the case of Azure, um, the name wasn't as simple as just an ID. It seemed to have two different components in it. So just given that example, I'm thinking we just define individual fields inside of the protocol itself and not try to abstract anything out.
Yeah, I totally agree. Then you're freed up if endpoint means something subtly different in
Right.
one versus another. Um,
Right. Okay.
then you can just document what it means for each protocol, and you don't have to try to come up with something that works for everybody.
Okay. Sounds good. Um,
And it also saves you. So in the future, when someone defines a new protocol that doesn't have an endpoint at all, you don't have to special case that one. You can
right.
just leave the field out.
Right. 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 Yeah. So I like the idea that all of this comes from the bucket access grant request. Bucket access, bucket provisioner grant bucket access. The gRPC API. So that would mean the gRPC API would have to have a. Okay. So thinking that through a little bit more, should we have well-defined fields for
Yeah,
getting information back?
I think that for each protocol, there has to be a specific set of outputs from grant access that must be filled in. And if they're not, it's an error. And you can't specify anything extra either. So you always know exactly what you're going to get with no opportunity for opaque parameters to go either direction at
Makes sense.
access time. No, I'm sorry, I shouldn't say either direction. You can have opaque
One
parameters
direction.
coming in from the bucket access class.
Right.
But coming out, there's nothing opaque so that when the downward API passes it down, pods know exactly what they're going to get, and no more, no less.
Right. Makes sense. Okay. So if we use this bucket info object, I think it gets pretty clear for anyone who's trying to write an application that leverages Cozy. Pretty clear in terms of what they need to read, what they need to support. Um, and
So
and
again,
and like we just talked about, huh?
I'm curious, why make this look like a Kubernetes object at all? What is the advantage of that?
Oh, versioning and just familiarity.
Okay.
We went alpha one. So we need some sort of version. And Kubernetes API has these fields, for better API management. Um, sure, things like metadata, name and namespace don't really apply, but yeah, it's rich and people understand this.
Yeah, I'm trying to think through, like, does this put any requirements on consumers of Cozy that are superfluous? Like, if
Import,
I
sorry.
let's say that I am one of these customers that has an existing pod that just consumes buckets through the standard S3 interface, and I don't want to change my application at all. So I need to have an init container that's going to do the
Right,
translation.
right.
Like, what are the requirements on that init container? Does that init container need to like import Kubernetes libraries to parse this thing? Can
We
it
just
just
need to
be
be
a,
able to parse this thing. I mean, we could ship the library separately.
well, that's what I'm just trying to think through in my head. Like, could I just have like a little Python implementation that does parses the JSON and
Yeah,
writes out some files and it's no big deal?
Yeah, Python will just parse it as a map. So yeah.
Right, but like if I do that, do I miss out on all the purported benefits of versioning and everything else, right? Because
I
if
mean,
what we're saying is we were doing this for the versioning, but then we expect actual users to just parse it with a little Python program, then like they're not getting any of the benefits of the versioning and the naming.
no,
They're
no, the
just
versioning
it's
is
just a
absolutely
JSON
required.
blob for
No,
them.
no, if they don't care about it, or if they don't um you know if we don't have versioning, what ends up happening is our API might evolve and their clients will not know how to use it.
Right, but like part of the magic of API versioning with Kubernetes is that like the server can support multiple versions and the client can tell the server, hey, I speak beta v1. And so even if the server speaks beta v2, the server knows how to down convert to beta v1 for the sake of that client. In this context, the so-called server, which is the thing that's injecting this JSON file in there, has no idea what the client supports. It's just going to drop
Right.
some JSON in there.
No,
And if
but
it's
even
not
if
the
we took
version that the client knows how to parse, you're screwed, right?
even if we took out the version field, that still is is a problem.
Oh, right. But I guess what I'm saying is I don't think that we actually get any versioning from this. I mean, you can slap a version on it and say this is what it is, but if the client doesn't support that version, you're SOL.
Yeah.
I
We do though.
I
We do.
agree, but no, it should have been in the request object, right? If we want to say which version the workload requires,
Well, yeah, I
like
guess that's where I'm going is like, if we really want versioning, then there needs to be some sort of negotiation where at the time you instantiate your pod, you tell Kubernetes what version of the downward API your pod knows how to speak. So
and we
that,
discussed this a couple of times, but we kind of didn't want to go there at the protocol level, right? We thought about protocol version. Um,
right. But that, I mean, that would be like for S3 protocols. And we said that that's
but
not a
but
good
it's like the
idea.
same thing, right? It's the same thing of the same problem. And what happens
But
if the protocol evolves? What happens if we want
this
to
is what
push more
happens if
information?
our cozy API evolves. Like
Yeah.
if we ship beta v1 and then later we realize we screwed it up and we want to add a new field or take out a field or rename a field and call it beta v2, like all of our users that were accustomed to the beta v1 API have no way to get off of beta v1 and to go to beta v2. Like
No, they do. They need to issue a request for a beta v, like a beta v2.
right, but
Right?
that involves making sure that our pod, whatever parameters goes into your pod spec has a field for like requested downward API version.
Yeah. We can put that in the volume spec.
Okay.
It's a map. It's a string map. So currently we put the BAR name in there. We might as well put in download API version.
But yeah, that's where I'm going is if we think it all the way through so that, yeah, the guy who creates the pod can tell you what version his pod is expecting and that we can translate it if the version we actually have is not the same one, then you have a story. But like that's a lot of work to do that conversion up in the whatever is doing the injecting of this information is it has
How
to.
is it? I don't know. Like so the thing is, if you have a conversion webhook or something, it's going to be, you know,
Right, but
just
it just
it
means that
won't-
like you have to be able to like have a table of known versions and a requested version and then the data you actually have, and you need to have a way to map what you actually have to all the versions that you support, and you have to avoid to handle versions that you don't support. It's just more code. I mean, I'm not saying
it's not that
it's
much more complex actually, because you're going to evolve one way. You're only going to add fields for the most part. You're not deleting fields. And supporting multiple versions just it gets pretty easy. And
okay.
you add more complexity as you add more versions, and it doesn't really scale. Complexity itself doesn't scale exponentially. It scales, I would say, linearly.
Well,
Like you add more versions, you add a little more code.
as long as there's an intention to have a version negotiation, I'll withdraw my objection and say, yeah, if the user gets a chance to tell you up front what version he understands, then
So yeah,
then it
I,
makes sense to have a version coming down and so you know what you're dealing with.
what's the other option? Like, what's the other option without versioning? How will that be?
The other option would be to say you never ever change it. You just say this is the downward API and we're going to pour the concrete on it, and you can't change it in the future.
Yeah, that's not
Except in backwards compatible ways, right? You can always have that. You could say you can always add things that are optional. You can never remove anything. You can never add any new required fields. You can only add optional fields.
but that applies now as well.
Not if you have proper versioning, right? If you have proper versioning and the client can say, I want V1 beta 2 instead of V1 beta 1, then you have an opportunity to add new required fields for V1 beta 2 so that
Let me
clients.
put it this way. If it's V1 though, we won't be doing non-backward compatible changes, right? I guess if you could say, yeah, V2 we might.
I mean, it can't be semantically backwards. It has to be convertible. Like whatever the difference is between V1 beta 1 and V1 beta 2, you have to be able to two-way convert it losslessly. But like as long as you can achieve that, it can be backwards incompatible because you can losslessly convert it both directions. And
No, I
hide
don't
the.
think we can be lossless going from beta 1 to say alpha 1.
But this is how the Kubernetes version APIs are supposed to work, right? Is you get to say, this is the version I want. The server knows the version it has, and it's supposed to be able to do the impedance mismatching inside API server. And there's a bunch of magic to enable that.
So yeah, so the API server doesn't do the conversion at all. The conversion is done by, no, it's done by a conversion webhook. It's a webhook call for anything other than, I don't know what.
But it's hidden behind the, I mean, from the client's perspective, the API server appears to be doing it. You're right that the API server outsources it to something else, but
Right.
But from the client's perspective, it's all just magic inside the API server.
Right. Yeah.
What is the change? Like, what do you imagine a change here? Adding a new protocol? Or why are we
adding a new field? Let's say we want to add certs or something like that. Something smaller. So I went and looked at a bunch of S3 options. AWS.
But I think for that, we did have like quite a lot of long discussion on the S3 protocol version.
Yeah, so I can see these things evolving. Let me show you. So these are S3 specific parameters. Yes, max concurrent requests, multipath threshold, multiple chuck size, stuff like this. You know, these are.
Why are these relevant as a downward API? I mean, these are configuration options that any application can export out. Why does the cozy needs to be in control of these?
If cozy wants to say, like path style addressing has to come from cozy. But because only the backend can tell you what kind of addressing is allowed.
So that's added, but I mean the rest are basically a client configuration,
so is this,
right?
No, so is this.
Okay.
Is it enabled or not? So I'm just saying there can be.
It's not really like accelerate endpoint. You could ask the driver to push in the right endpoint.
But someone needs to tell it, right, that this endpoint is available.
No, the driver knows what type of endpoint it wants to push into the pod, right?
Yeah, I mean you could, yeah. So are you saying that we don't anticipate any new fields to be added?
No, I'm not saying that. I'm mainly looking at like the differences between what we discussed before versus like, are these evolutions of the protocol, like the signature version like we discussed, or anything like that? And then all workloads should somehow understand the new, the new type of downward API, because
So those fields we were talking about in terms of specification, in the sense that what does the user get to specify? So we said, signature version and specification fields would be something that we just assume that the workload understands, specifiable field. But in this case, we're talking about fields that come back from the driver in a response object.
Right. It's like this is the communication channel between the driver and the pod, the workloads, right? The pods,
Yes.
And now we're saying there is a version to that because what is going to evolve? The protocol is going to evolve. The driver is going to evolve.
The cozy API could evolve.
Right. So I'm trying to figure out, like, are we talking about adding more fields to S3 because we see that this is the case, and then we're going to bump a version if it's incompatible, right? So if there's a compatibility issue, we're going to bump this version, and then these workloads would have to specify I would like to get the previous version, for example, because I was compiled and my code supports the previous one, and then Cozy would have to be able to build the previous versions of all of these options somehow.
That's what's being suggested. For versioning to have any usefulness, I think that yes.
Or otherwise it will be rejected, right? That's the other option. Like you don't get your pod scheduled because the PV, like it rejects it, basically, right? The version mismatch from what is supported.
I guess, yeah, it would look a lot like an attachment error. Like your attachment to your bucket would fail if you requested a version that was not supported on the cluster where you were running. And you would get an event that would explain that, and then you could say, "Oh, okay, we're on the wrong Kubernetes version."
I would also be a little bit concerned of exposing too much of these complexities to the workload itself, like the version like the version string itself, the provisioner itself, like all these. Actually, they make some sense on one hand, but like it can be, it can cause confusion that the workloads will start parsing the metadata. Maybe I don't know what do you expect to have there, annotations by the driver or anything that breaks the compatibility, right, of Cozy in some way. Because
no, we don't want the driver to be able to offer any annotations.
Like the metadata there hinted that it might be a generic metadata structure, like
we could follow a discipline, but okay, so we could follow a discipline there, or in order to metadata is a standard way to define Kubernetes APIs.
But the user
it's
doesn't
definitely
get an
standard
opportunity
and extensible, but it's like for controllers that would like to talk to each other on various things, right? Right here, we're trying to be more descriptive about what we're communicating between the drivers and the workloads, so it also still remains compatible, right?
Yeah, it also represents like a resource that a user would create. It's there's that familiarity there. That being said, we don't need to have a metadata field to be Kubernetes valid object. And I don't even know if we need to be a Kubernetes valid object. Like, there's no reason. This is constructed on the fly. So
that was my original point, was we're making it look like a Kubernetes object when we could just make it a JSON blob.
Sure. I just wanted to have some sort of the API has to be defined. That's it. In the sense, if I evolve it, there should be a way for us to tell something has changed. And it can't be just we added a field. We should be able to say this is version 1, and the next one wherever we added the field becomes version 2. Right? We should have a structured defined API, right? We can't just throw a JSON out there.
What happens in the gRPC versioning scheme? What's there? Does that, because like the drivers communicate with gRPC, right?
Mm-hmm.
So how would they, like if more information is needed, right?
Mm-hmm.
How do the driver represent that it supports this version and not like a newer version versus an older version? The driver also should have this version somewhere.
So the gRPC version is separate, and it really comes down to like what version of the protobuf you compiled your application with. Because we have this with CSI, right? We've evolved CSI numerous times, and you can just add new stuff to your gRPC API, and gRPC is backwards compatible.
Right, but you still need to +1 your version ID number or something, right? Something.
I don't think that the version number gets represented on the wire. I think with gRPC, it's just everything's infinitely backwards compatible, and so as long as basically the two sides just negotiate down to whatever the lowest one was using effectively.
I see. So you keep on in gRPC the previous protocol and the new protocol, right? And somebody needs to translate the server or the client.
You can add new methods and you can add new fields, but like if an old client is talking to a new server and the server sends back some fields the client doesn't understand, they just get dropped. And if the client is newer and the server's older and it calls a method that the server doesn't implement, you just get an error. And so, yeah.
But if you really want to create a new version, like non-compatible, backwards compatible, like we're discussing, right? Then
we've never done that within CSI, and CSI is what I'm most familiar with. CSI is infinitely backwards compatible, and we have these capability queries that you can make from the CO queries the plugin to say, like, do you support this? And the plugin has to say, yes, I support it, before the server will even try. That way, when you add a new feature, there's an inline negotiation to say, like, do you support the new feature? Yes. Only if it says yes, then call the new functions. Otherwise, they might return an error. So it's all in line as far as I know.
I think that's when you keep backwards compatibility, like you said, in concrete, right? But I think, like, when I remember the gRPC services can somehow represent, like, I could create a new version of a message or a new version of a protocol, but maybe I'm not accurate here. But in any case, I think my question is, does this have to also be extended to the drivers API in this case? Like this version, how does the driver communicate what version it needs to or supports or expects, right? It's like there's another party here. It's not just Cozy.
If we do it like CSI does it, then what I would expect is some sort of capabilities query that the Cozy would make down to the driver, and then as we added new features, we would wrap them in capabilities, and we would only invoke the new methods if the driver asserted the capability.
And we're saying if you're just adding fields, as long as it's backwards compatible, it's okay.
Well, but there's also there are explicit gRPC methods in CSI called like get node capabilities, get controller capabilities that return these bit masks of supported capabilities.
But they don't lead to adding fields into the request. The request object is compiled and
right. But you can do things like say, we're going to add a new parameter to this function, and technically it's optional. But if the client asserts the capability, then it can be assumed to be required and not optional by virtue of saying that the capability is there. You can do things like that, or another example for like resizing in CSI, like by default, you don't have to implement any resize functions, but if the plugins say that they support resize, then the CO will call the resize methods and expect them not to return an error. If you don't have the capability, you don't have to implement the methods at all. So things like that, where the method is optional unless you say that you have it, then it's not optional.
Right. It's the method itself. It's like a completely different method. So okay,
it's at the gRPC layer, it is optional, but like semantically, you define some RPCs that mean that if you say you have this capability, then you actually have to have the capability.
I mean that would be a good enough evolution expansion path for us. So right now, what the decision that we need to make is either we add versioning to both gRPC and the download API, or to neither. Isn't that right, Guy? That's what you were saying, right?
I mean, I said also you mean the driver, right? Did you mention
Yeah.
that? Because yeah, I think in some way the first party that needs to provide this information is the driver. So what is that communication about, right? What are we going to tell the driver? The cozy version or like this? I'm not sure. And also, I'm quite worried that this format is too identified with Kubernetes that it will be too much expected to be a CR, like a CRD.
That was my first instinct. Was when I saw this, I was like, this looks like it's intended to be a CRD, but we're not
Right.
using it that way. But
and it might confuse like the intention of like if you see this snippet somewhere, you'd expect to like kubectl create it somehow. Right?
I see what you mean. Okay, I think that's a strong point actually. We can take the Kubernetes bits out of it. That still leaves the question of versioning though. We could still have a version.
Right, but the cozy does have we do have a version for the CRDs, right? So the CRDs for the cozy controller are a version. So the cozy controller can then be instructed, like have a new version and then get more information or return more information, right? That's okay. And do we have anything like that with the drivers? Do the drivers have any access to any versioning from cozy, like a cozy version or the bucket request or the bucket access request versioning? Is that somewhere?
For driver versioning, what I recommend is we follow what CSI did and have capability bits.
No, but that's not versioning though. That's like adding new services.
Right, but I mean,
it remain the same.
It gives you the ability to add features over time and know if and negotiate between the client and server support for those features, which is effectively what you want out of versioning, right?
Well, not really. Adding new fields to the request itself or expecting different fields from the response is not the same as asking for capabilities.
Well, if you're expecting a new field in the response, then older implementations can't implement that. And so there's nothing you can do will make the field appear. You basically have to query, can you supply this field, yes or no? If yes, then give it to me and I'll put it in there.
I think what we should do is there's a provision, a get info call. In that we should have a in the response to get info, it should respond with the provision name and either supported versions or just supported version.
I don't know. I don't think it costs us anything to have a capabilities API like CSI has, and that can just initially return like an empty set, and then over time
we can also add it, right?
Well, the problem is if you add it, then how do you query whether it exists, right? You need a way to bootstrap your mechanism to be able to start negotiating. So being able to query capabilities,
right,
and
okay.
have the plugin say I don't have any capabilities is at least the beginning of that conversation. Because then you force people to at least be able to say I don't have any capabilities. I mean, maybe you could achieve the same effect by just catching the error when you invoke the get capabilities call and noticing
no
that
such method or
the method isn't there and say, okay, I guess he doesn't have any capabilities. That would work too, probably.
Right. And then this should allow us, like the capabilities thing is a way for the cozy controllers to talk to the driver and be knowledgeable about what they support, right? When as cozy evolves and the drivers might still be lagging or something like that. That's kind of what we're saying in that capabilities aspect, right? Or is it also about the matching things from? Well, it should be able to match things from the request as well. So the client could also be more involved than the driver in some way. But yeah, now we're trying to get the answer from the driver back to the workload, right? And we're asking what should we communicate back to the workload? In terms of version.
Mm-hmm.
So what did you say about that? Do you want to have something that the workload describes? I want to get this version and it will match, or it will convert, or what was the options
No,
there? I guess
if the driver isn't going to have a specific version, and if the driver isn't going to return a versioned object back,
but that's only for driver implementation, which is lagging behind the standard. But what about like the workloads? So if I have an older, container image that could read this version, the first one, and the standard evolved, and now there's, I don't know, a change, like, I don't know, the protocol. There's another field, for example, top level, whatever, right? I don't know, or something within the protocol, for example, like, and the workload doesn't read that, right? Or it's a change of structure so that the workload needs to look up not under S3, but under S3 also V4, right? Something like that. I don't know. And then,
well, parsing, you can ignore unknown fields.
but the workload is older, right? We're talking about a case where the workload is like lagging behind the standard, right? And then
that's what I mean.
Tries to read this.
Right.
This is the first version.
Yeah. So when parsing JSON, you can ignore unknown fields. So if you see a field you don't understand, just ignore it. So what that means is we can evolve this. As long as, again, like, as long as we're not deleting fields with important information, we're only adding fields. That is, we are always backwards compatible. I think.
But say use so what the example you gave before, the path style for S3, right? That's like a breaking. If I represent a path style true, and the workload doesn't read that and uses a bucket style domain.
Domain style.
I don't know. Actually, we talked about that. This will be the endpoint URL will include whatever bucket name is needed there.
No, it's just some new parameter, right? It doesn't have to be path style, like whatever.
No, but something that if you don't use the right value, it will not work. Right? That's the case where this kind of breaks down because you don't support this version. Like the workload doesn't read this new value, and it just fails. Might be okay to say, okay, this workload is not good. It's not compatible. But then what's the purpose of the version? What would the workload do?
Yeah, that's a bad behavior. If you have to only do additive things as you make changes.
Yeah.
No, but it is additive, right? Or you mean additive in the sense that
not if you can take away something that used to work, right? If you're changing from one path style to another, such that someone who depended on the old one can't get it anymore, now you've subtracted something.
Okay, so you're saying that for this example, let's say it's a path style thing, just for the example, then I would have to represent this somehow as an option in the bucket access request, for example, and then I would be able to match what the let's say this, or always, like, unless I queried the workload somehow from the pod spec and know that it supports the new version, I couldn't provide this new behavior, right?
That would be one way, yeah, is to make you specifically ask for it up front and fail if you can't have it, or you could just require that you continue to return both things, like the old thing that used to work plus the new thing. And as long as the old thing that used to work continues to work, even in the presence of the new option, then you have no problem.
Yeah, but we're saying that might not be possible. So
right. So in the case where it's not possible, then you're not backwards compatible, and you have to go through like some sort of formal negotiation.
Didn't even exist. So let's, right now we don't have path style access. Let's say we go ahead with this, and then we find that someone's trying to port from a provider that provides path style access to a provider that doesn't, and
no,
they have no way
it's
to
the workload. That. It's what the workloads are compatible with that matters. If the workload if the workload cannot understand path style access and only understands the endpoint
domain style. So here's the thing: the workload still needs to know what style is supported, and let's say we never had that field to begin with, and we added later on, but then.
Right, but the way we fix that is we decide as the people designing Cozy, we get to say this is what you must support, and then everyone can rely on that being the minimum bar.
I'm saying, what if we missed the field we added later on? There's an old client which cannot read that, and there's a new client which gets to, which can understand it.
as long as you can also specify the old field in the bucket is still usable, then old clients won't care that they're missing out on some new feature. That would be the key, right? If you add something new, you have to add it in a way that old clients continue to get the behavior they used to get and nothing breaks. And new clients maybe get something new and fancy, but old clients continue to behave as they used to. So like the feature would have to be purely additive. Like it would have to be a second path to the same bucket where the original path continued to work.
So you would need, so unless you want to be very wasteful, right? And if it sorry, so if this change means, let's say, accelerated input, I don't know, I'm just throwing things, but something that requires more provisioning on the driver side, right? To provision something different or additional, right? So you're saying always provision the base as well because your client might be older. That's one option.
Right.
And then this is backward compatible. Or we can somehow communicate the client version, the workload version, back to that flow, so that we know what the client expects. But then these drivers should be able to support backwards compatibility of those requests as well.
I mean,
or fail those, but something.
This is why designing a standard like CSI is hard, because you have to make the decision up front for what the minimum bar is, and then you have to stick with it forever. So like you have to be careful about deciding what is in and what is out, because stuff that is in you can't ever remove. And if like the endpoint is expected to be a domain style endpoint and people are expected to depend on that, then you can never take that away from anybody. And so we have to just decide, like, is that how we want to make it, or do we want to require path style endpoints for all implementations, and then say, look, if your implementation can't support that, then you can't support Cozy. And we can draw the line wherever we want, but we have to stick with it forever, and then only add to it. Never drop things that are in the standard.
Yeah, that's a discipline we'll have to follow.
But so this is, we're sort of off the original path of, the whole purpose of defining a versioning mechanism is we're doing a favor to our future selves by when we come up with an idea tomorrow that we don't have today, we can gracefully add it without having to jump through a bunch of hoops. That's the whole point of thinking about versioning up front. We don't have to. We could leave it out. It'll just be a lot harder to add stuff later.
You mean not just add, I mean, like actually modify the behavior of things.
Right.
Right.
That's what will become impossible without version.
Not necessarily impossible, but just you'll have to go through a bunch of extra steps.
You'll add it after. The version will be added later.
So and the problem is we never know what we're going to think tomorrow, today, right? You can sit around and try to think of what things we might want to add later, but it's always possible to have an idea, a new idea.
Yeah.
I don't know. I like endpoint, access key, secret key, bucket ID. I don't know. That could be
bucket name.
Bucket name, maybe.
Sure. No, I still don't think we've reached a resolution on version. Do we want to have a version field? I think we should have a version field. Just the amount of, the amount of effort that's going to take to work around it is much higher in the future. It's going to be very likely much higher than just having one right now, and having
it's the same. Think about it. Like if you don't have this field and you add it later, it's pretty much.
I'm fine with having the version field in as long as it's tied to something on the Kubernetes side, so that people can say what version they want, and we can do some sort of conversion.
Yeah, let's go with that. And we can get rid of some of the fields that we mentioned. Like we can get rid of, I don't know, kind and metadata and even provisioner.
Yeah, provisioner shouldn't be exposed because that's a proprietary detail, I guess. Well, you can see it
Probably
in
not.
your bucket class.
I mean,
Yeah.
you get
I can
access
see
to the
workloads reading this and making decisions based on the provisioner. So it's like
right. That's the concern is what if people start writing their workloads to look at the provisioner field and have different behavior depending on what the provisioner is. That would be.
I mean, is that so bad though?
It would kill portability is what it would do.
Right. It's like,
It would mean that the moment you start doing that, your pods are no longer portable.
you can encode a whole JSON there, and then I don't know. You can probably, but I mean, just you can probably encode there something that will allow the client to read and make decisions that break portability.
Yeah, I feel like if the workload wants to do something different depending on what the provisioner is, there are other ways to achieve that without us making it easy.
Okay. All right. So we'll make the version. We'll just call this field version, and we'll just use the last part because this is assumed it's coming from Cozy. It has to be that.
Possibly, yes. Yeah.
All
So
right.
you're saying remove the kind, simplify the API version, remove metadata and provisioner.
Yep.
Okay.
All right.
So what do you want to do with the path? What did we say about path style to begin with? That the endpoint would include the location of the bucket name, or
no? It has to be here. It has to come back from the driver. We cannot. You can't tell the driver, give me like S3. Amazon S3 supports both. But they themselves recommend to use one or the other. I believe they recommend that we use the domain style access. But there are, path
for
style is
DNS.
is a function of DNS that you have running. And if you don't have a sufficiently advanced DNS server that can translate requests for you.
Well, hold on, but what if the endpoint is just an IP address? What if it's http:/10.20.30.40?
No, I'm saying endpoint is not enough.
No, but I'm saying, like, is that a valid endpoint?
It is. It is.
So then, given that, there's no way to do anything without path style access, right?
Right.
No, path style access.
IP basically means
path style access just means. Oh, are you saying you can't have a subdomain if you have that IP address?
I'm saying if the endpoint is the IP address, there's no way to concatenate your bucket ID with an IP address and get something useful.
You can only in a path style manner, right?
Right.
That's the only way.
So these fields are enough. We just have to, when we document them, we have to be extraordinarily detailed about what is and is not allowed.
So path style access is a common field that's expected by pretty much every big data client.
Yeah, I don't see any problem. Yeah, but before when we were talking about it, I was thinking, like, if you want to add it as like an extension, then that creates problems. If we make it part of the core and just say everything must support path style access, then we're done, right? Because then clients at least know that they can depend on that, and servers either support it or they can't do cozy, and that's a fine state of affairs.
I don't think this is what it means. It means that the driver can specify to the client how it should address the bucket. So it's not that the driver becomes responsible to support both, because we didn't add it to the request object by the workload, right? We're just saying that the driver instructs the workload how to use that bucket with that.
Right, but I think we accomplished that by documenting what the fields mean and then testing every possible iteration or interpretation of that documentation, and implementations either pass the tests or they don't. And we have to think through all of the crazy things that a client might do in response to those two fields.
So we're saying though that the clients have to support it. That's what we're saying here.
Yeah.
By saying that.
So here's the usual style. This is from Hadoop documentation for S3 integration. So they have a separate endpoint, which is simply just the IP address or the host name, or it's not the FQDN, it's of the entire bucket, but it's just the FQDN of the service itself. And then you add path style access or not.
Right. It just mirrors from the SDKs, right? The SDKs
Yeah.
have this.
Yeah.
But there are some quirks from the SDK parsing of this, right? So if you provide, like we said before, if you provide path style false, you provide an IP, and it doesn't make any sense, right? So there are things that we're just saying that we are ready to accept whatever the Amazon SDK is doing with this. From the driver's perspective, like the driver will, if the driver pushes an IP and then says, I want pass out false, it should accept whatever the SDK is going to do in some way.
But I think we would be doing our users a favor by not letting the driver specify path style on or off, and we just force them one way or another, or force both.
No, we can't. We really can't.
It's a question to the driver. It's basically a question to the driver. How does your bucket, allow addressing?
Yeah.
Should I prepend the bucket name to the domain, make it a subdomain of the endpoint that you provided, or should I append it to the path as another path component, right? It's really an instruction to the workload how to connect, and you can
right, but
sometimes provision the bucket to do both, but not always. Right?
It's a function of the DNS server that's running in the infrastructure, and not a function of S3 itself.
But I want to turn the question around and say, if as the cozy specifiers, we force everyone to go down one path or the other, will that exclude some implementations that we don't want to exclude?
Yeah.
Okay.
So
that's the important question to ask, is like, if we say, look, everyone has to do path style access, and then someone says, hey, I can't do that.
Actually, why is that wrong?
Sorry?
Huh?
I mean, why isn't that enough? Like saying cozy only allows you to provide a path style access for
because Amazon wants to move to domain style access.
But as long as Amazon can support path style access, like, who are we hurting by not
What
allowing?
if it comes down to they don't support path style access anymore?
But you're saying that their SDK will not support it as well?
No, I mean the backend itself.
The backend, if it doesn't, then the driver will say, oh, so you're saying the driver doesn't have a response to say that it doesn't.
Well, but can the driver have a fallback? So, like, here's an endpoint that will always work, and like, as an extension, if you take this string and concatenate the bucket name to it and do a DNS lookup, you might get a better endpoint than the default.
So the SDKs understand how to construct the URL if you just give this parameter. Every SDK understands it.
Right, but if the endpoint is an IP address, then they don't understand it.
No, they'll fail out. They know how to parse that. So that's a wrong specification. I think that's okay. So if a driver gives us that wrong specification back, I don't think we have to do anything. It's the driver's fault at that point. The SDK, the client SDK will fail.
Okay, so what you're saying is we would leave it unspecified at the cozy level, and then if a driver returned an endpoint that involved a domain name and a bucket name and it supported domain style access, then you're great. And if it returns an IP address, then you just kind of assume that it supports path style access, and again, you're great. And if you do anything wrong, it's not our fault.
Mm-hmm.
It's between
the driver
and your driver.
Yeah.
We can do that. I guess we should write down those assumptions then in the documentation and say, okay, look, these are the two fields we're providing. Our expectation of plugins is that if they return this, then that, and et cetera, just spell it out so people understand what the expectation is. And then maybe you can support both that way. But it's not ambiguous.
This is another field I think we should add, SSL enabled.
But can't you just encode that into the HTTP versus HTTPS in your endpoint name?
So the endpoint should not have HTTP or HTTPS.
Why not?
Endpoint
does, then it's basically a description of both of these, right?
Yeah, except sometimes the endpoint is specified as S3A : / or S3 : //.
Okay, well, that's just another thing we need to be precise about. We need to say like the endpoint should not include or must not include a URL
Scheme.
prefix. And, if you want TLS, you set this field to true. And if you don't want TLS, set this field to false and set the port number over here, etc. A URL
But I
is more
don't think the
convenient.
endpoint is never on itself, like to the SDK. You never say a 3 : anything, right? This is a CLI tool thing, but from the perspective of no, you say S3 dot. I mean, I thought you said S3 : / or something.
That
like
is also
protocol.
valid. Yeah, S3A : / is a valid endpoint.
Well, it's a valid
Not in the SDK.
in certain contexts, right? Like for CLIs and maybe for other tools, but
Right.
But like I can't go into Firefox and type that and get a sane response. I don't think.
If Firefox doesn't understand that scheme.
Right. That's what I'm saying. Like it's not a standard. The only point I was trying to
But
make.
generically speaking,
it's not an
what does
endpoint.
it mean?
Right.
I mean, to like if we're talking about from a generic provider perspective, what does S3 : / mean? It's just a protocol name. We're already having a context for the S3 protocol there, right?
Yeah, it's for bucket addressing. So never mind, that's not for endpoint addressing. So when you do S3 : /
Right. Exactly.
Yeah.
Exactly. Right.
So if we go with the URL style endpoint, you get things like host names, IP addresses, TLS versus non-TLS, and the port number all for free in one field. If we want to say the endpoint,
so the issue is that at that point we're expecting the client to parse that out. The thing is, it's SDK expects it to be a separate parameter. Why not?
Okay, well, so that's fine, but then we need a field for port number. We need a field for TLS.
No. So the convention is endpoint doesn't just have the scheme. That's all. Everything else is in the endpoint, the port, and it can't have any path parameters. It has to be IP address, port, or subdomain, domain, and port. It can't have path parameters.
But I mean, but we just have to spell it out. We have to say the endpoint is this, right? It is just an IP address or a host name with an optional colon and port number, and no slashes, no schemes, no nothing else. And as long as we're specific about that, then we stay out of
somebody
trouble.
also needs to read this JSON anyway. I mean, it's not that it's automatically read by the SDK anyway. So
but it is a pain to parse